take a look at number 1. This is a binomial. It only has 2 terms. Is there a number that goes into both terms? 2. So we pull out a 2. And if I pull a 2 out, what am I left with? X plus 3. Good. Now, these instructions just say factor. So on these top 3 rows, all you're doing is factoring and you're done. On the bottom 3 rows, we're actually going to find the roots. So number 2, is there a greatest common factor? 2x. So I pull out a 2x. What's left? 3x minus 2. Okay. Now, how do I know I'm not going to use the box? Well, the box is only used when you have like an x squared. So you pull out your greatest common factor. If you're left with an x squared, then you would use the box. Number 3, what is the greatest common factor? There isn't one, so technically it's 1. So number 3 is considered prime. Okay, let's look at number 4. Does number 4 have a greatest common factor? No. Should we use the box? Yeah, we have an x squared, so let's try the box. And remember, you fill in the first one and the last one. And what's the next step? Multiply those 2 boxes together, and I get negative 15x squared. If that 15 is negative, what do I know about the signs? They're different, and what am I trying to create? A negative 2. So if that 2 is negative, what does that tell me about the signs? The bigger one is negative. So I'm looking for 2 factors of 15 that have different signs and add to be negative 2. So I'm going to go through and list all the factors. 1 and 15, 2 doesn't work, 3 and 5. Can I create a negative 2? Yeah. So it would be 3x and negative 5x. Everybody get that? So we look at the top row. What does the top row share? An x. So up here we're going to have what times x is x squared? X. What times x is 3x? 3. And what times x is negative 5x? And we check by saying, is negative 5 times 3 negative 15? Yes. So my factors are x plus 3 and x minus 5. Those are the answers to number 4. Any confusion on how that works? Okay. Let's do number 5. So we draw the box. X squared and 6. That's going to give me a 6x squared. What do I know about the signs? They're the same and they're both negative. So 1 and 6 or 2 and 3. Which one will give me a negative 5? 2 and 3? Well, isn't 1 minus 6 negative 5? So does this have 2 answers? Right. Is 1 times negative 6, 6? No, 1 times negative 6 is negative 6. So you have to be careful. Sometimes it will look like it works, but the signs will be wrong. So negative 2 and negative 3 is the only correct solution. So minus 2x minus 3x. What does the top row share? X. What times x is x squared? X. What times x is negative 2x? And what times x is negative 3x? Is negative 3 times negative 2 6? Yes. So I did it correctly. So my answers are x minus 2 and x minus 3. Okay. Number 6, can I pull anything out? Is there a greatest common factor? No. The last two share a 7 and the first two share an x, but there's nothing that's shared all the way across. So, draw the box. X squared and 49. So 49x squared. Are there factors of 49 that add to be 14? 7x and 7x. What does the top row share? X. What goes here? X and here. 7 and here. 7. So one of my factors is x plus 7. And the other is also x plus 7. And if you're lazy like me, you would just do this. X plus 7 squared. Okay? Number 7. X squared and negative 56, which gives me negative 56x squared. What do I know about the signs? Signs are different, and the bigger one is positive. So we'll go through all the factors. 1 and 56. Does 2 go into it? It's even. So 2 and 28. Does 3 go into 56? How come? Well, if I add 5 and 6 together, I get 11. Does 3 go into 11? No, so it doesn't go into 56. 4 and 14. 5 doesn't work. Does 6 work? Well, 3 didn't work, so 6 cannot work, because 6 is made up of 2 times 3. So 7 and 8. Will one of those give me a 15? Which one? 7 and 8? So it's going to be 7x and 8x, right? Ah, good. I was going to go until somebody caught it. 7 times 8, is that 56? Negative 56? No. So what if I make like that, negative 7, positive 8? That doesn't add up to 15. So if I would have tried it here, I would have got x, 7, and 8. Is 8 times 7 negative 56? No. Well, what if I would have done this? Now it equals negative 56, but where's the problem? Do these add to be 15? No. So this one does not factor, so it's prime. If a quadratic is prime, does that mean it doesn't have any roots? No. It just means that the roots are not whole numbers or fractions. There's something worse. Or imaginary. They might not even be real numbers. Okay, let's take a look at number 9. Do the terms in number 9 have a greatest common factor? Yes, what would it be? 2. So I'm going to pull out a 2. What's left? X squared plus 6x minus 7. Okay, that makes the factoring a lot easier. So always look for a greatest common factor and pull it out if you can, if there is one. So now we build the box. X squared and negative 7. Times those together. Negative 7x squared. Are there factors of negative 7 that add to be 6? 7 and 1. So minus 1x and plus 7x. What does the top row share? X. What times x is x squared? X. What times x is negative x? Negative 1. What times x is 7x? 7. Is 7 times negative 1 negative 7? Yeah, so we must have done it correctly. So what are my factors? Well, don't forget the 2. X minus 1 times x plus 7. That 2 is part of your answer. It is one of the factors. Okay? Take a look at number 12. Do the terms in 12 have any common factors? X. So I'm going to pull out an x. What's left? 4x squared plus 4x minus 3. Okay? When we write our answer in the end, don't forget to put the x with your answers. It is one of the factors. So, draw a box. 4x squared minus 3. What's my next step? Multiply those together. So I get negative 12x squared. What do I know about the signs? They're opposite and the bigger one is positive. So 1 and 12, 2 and 6, 3 and 4. Can I create a 4 using one of those sets? So negative 2x and 6x. Does anybody have trouble doing that or not understand what's going on? We're all okay? All right. So this is a little bit more tricky. What does the top row share? A 2 and an x. So I'm going to write 2x. Well, what is 4x squared divided by 2x? 2x. 4 over 2 is 2. And x squared over x is just x. Anybody not understand that? Okay. What is negative 2x divided by 2x? Negative 1. And 6x over 2x is 3. Is 3 times negative 1 negative 3? Yeah. So what are my factors? X, 2x minus 1, and 2x plus 3. And remember, on these top 3 rows, all you're doing is factoring. You don't have to find the roots. You just factor and you stop. Okay. Now we'll move down to solving, finding the roots. So number 13. Can I pull anything out? Pull out a 4. What's left? X plus 4. And now if I want to find the roots, I set this equal to 0. Is that 4 out front needed? No. How would I move that 4 to the other side? Divide. What's 0 divided by 4? 0. If you have no pieces of pizza and you cut those pieces into 4 pieces, how many pieces do you have? None. So this number actually has no bearing on the roots at all. So if you're factoring and you pull out that 4, you need to hang on to it because it's one of your factors. Yeah. If you pull a 4 out and you're finding the roots, you can just forget that that 4 was ever there. Now, if I divide an equation by 4, it will change the equation, but it's not going to change the roots. Just like if you take a quadratic and times it by 2, it will be steeper, it will be taller, but the roots will remain unchanged. So when you're finding factors and you pull a number out, you need to hang on to it. But if you're finding roots, you can just divide that number out and forget it was ever there, unless they share an x. If you pull out an x, then you have to keep it. And I'll show you that in a little bit. So if my factor is x plus 4, what's my root? Well, I subtract 4, and x equals negative 4, and I'm done. So this graph crosses the x-axis one time, which I should have known because it's an x to the first equation, which means it has one root. Okay, my next one is an x squared, so how many roots should it have? Should have 2. Can I pull anything out? I can pull out a 6x. What's left? X minus 2. Now, is that 6 going to change my answer? No, so I can get rid of it. But I set this equal to 0. Well, what number makes that 0? Well, so if I said a times b equals 0, what do I know about a or b? One of them is 0. So a is x, and b is x minus 2. So either x equals 0 or x minus 2 equals 0. Well, this is one of my roots. Whenever you pull an x out, that guarantees that the graph crosses the x-axis at 0. What's my other root? Add 2, add 2. So those are my roots. Whenever you pull an x out, your first root is always 0. And then just set the other factors equal to 0. So if you pull out a number and you're finding the roots, you can just get rid of that number. You don't need it. But if you pull out an x, one of your answers becomes 0. Okay. Look at 15. Can I pull anything out? No. Does that mean it doesn't have roots? No. Well, can I set this equal to 0? Could I solve 9x plus 16 equals 0? How? Just subtract 16, and then divide by 9, and that's my root. But that only works if there's one answer. If it's an x squared, and it doesn't factor, and you set it equal to 0, you don't know how to solve that yet. I think we'll get to one of those in a little bit. Okay, 16. Can I pull anything out? Nope, not an x. Can't pull a 2 out. They all have to have one. Do they all have an x? No. Do they all have a 2? No. So we just build the box. X squared, negative 16. Multiply those for negative 16x squared. Are there factors of negative 16 that add to be negative 6? Negative 8 and 2. So negative 8x and 2x. What does the top row share? X and x. What's my next value? Negative 8, and down here would be 2 is 2 times negative 8, negative 16. Yes? So my factors are x minus 8 equals 0, and x plus 2 equals 0. My roots would be 8 and negative 2. We okay with that? Okay, let's look at Um, I think we don't have a, oh well. So, um, if you run into a quadratic where you're finding the roots and it's prime, it still has answers, but you're just going to write prime or unknown. Okay, and then in probably a couple weeks, I'll teach you how to find it. It's a lot harder than finding them when they are nice numbers. But let's take a look at 18. Oh, actually, there is one. Okay, we'll do it. So build the oh, can I pull anything out? Do they all have a 2? No. So x squared and 16. So, or 36, sorry. So 36x squared. Are there factors of 36 that add to be 12? 6x and 6x. So I have an x and an x and a 6 and a 6. What do you know? What's different about this quadratic? So I have x plus 6 equals 0 and x plus 6 equals 0. How does that happen? Well, on the x-axis, it looks like this. Oh, ah, thank you. So whenever you have two roots that are the same, the graph hits that once and kind of bounces off. Okay? Look at 19. X squared and negative 56, which is negative 56x squared. What do I know about the signs? Different, and the bigger one's positive. 1 and 56, 2 and 28, 3 doesn't work, 4 and 14, 5 doesn't work, 6 doesn't work, 7 and 8. Can you create an 8 using those? Nope, so this one would be prime. It still has roots, but they're not whole numbers. Well, they're not integers. They're also not fractions. It's some nasty square root answer that we'll get to later. Okay, 21. Can I pull anything out? Pull out a 2. Do I need the 2? No. So I can just write x squared minus 4x minus 21. If I were factoring, I would need the 2. But since I'm just finding the roots, I don't need it. Build the box. X squared and negative 21. So negative 21x squared. Are there factors of negative 21 that add to be negative 4? Negative 7x and 3x. So x and minus 7 and 3. Did I go too fast? So x minus 7 equals 0 and x plus 3 equals 0. So what are my roots? So 7 and negative 3. Do I need that 2? No. No. If I were factoring, then my answer would be 2 times x minus 7 times x plus 3, and that would be the end. So if you're factoring, that would be the answer, but if you're finding roots, those are the answers, and that 2 doesn't come into play. Now, what if you forget to pull the 2 out? Can you still factor it? Well, so put your pencils down. Just watch this. 2x squared and minus 42, and 2 times 42 is minus 84 x squared. So I'm looking for an 8. 4 and 20, that's not going to work. 6 How many times does 6 go into 84? 14? No. 6 and 16, that's not right. 8. It's 14? Oh, well then good. So, plus 6x and minus 14x. So this would be 2x, x, 3. And that would be minus 14. And that works. Okay, so my factors are 2x minus 14 and x plus 3. Are those the same factors we got the other way? Why are they the same, Sydney? I can pull a 2 out of here, and that would be 2 times x minus 7. So even if you forget to pull the number out, you'll still be able to find the answer, but in this case, I was finding the factors of 84 instead of 21. It was 4 times bigger than the other one. So even if I set these equal to 0, I still would have got negative 3 and 7. So it will still work, but it's going to make your life a lot harder. So make sure you pull that out every time. Okay, 24. Can I pull anything out? An x. Do I need that x? Yes. What does that x do for me? One of my roots is 0. So this is an x to the third, which means it has 3 answers. My first answer is 0. And then 6x squared minus x minus 2. Put it into the box. And negative 2. What's my next step? 6x squared and negative 2 is negative 12x squared. Are there factors of negative 12 that add to be negative 1? 1 and 12, 2 and 6, 3 and 4. So 3x and 4x. What does the top row share? 3x. What is 6x squared divided by 3x? 2x. What is 3x divided by 3x? 1. What is 4x divided by 2x? 2. Oh, thank you. Yeah, and I would have found that out. 2 times 1 is not negative 2, so thank you. So now I have the factor 2x plus 1 equals 0, and the factor 3x minus 2 equals 0. How do I find the root for the first one? Subtract 1. Those cancel. And then I divide by 2. So negative 1/2 is one of the roots. And what's the last root going to be? Add 2 and divide 3. So I get 2/3. Okay, any questions? Because, so when I factored out that x, I really have x times 2x plus 1 times 3x minus 2. And each one of those has an x, which means each one of them has a root. So I set all 3 of them equal to 0. Well, when I set x equal to 0, I just get x equals 0. So anytime you factor out an x, your first root will be 0. And then the other 2 factors will tell you the other 2 roots. Okay, so you got about 15 minutes to work on this. It's due tomorrow. Good luck.